Got this frustum, which is made by taking a cone and just slicing it perpendicular to the axis, removing the smaller cone. So if I kind of rebuild the cone, I would draw a line up here, and then one down here. And I could actually create a triangle, because the very center here is going to be the center of the base. Now, if I want to find the curved area, it's going to be the curved area of the original cone minus the curved area of the bit that we've taken away. That's what I'm going to need to do. And that's going to equal the two circles added together. So let's focus first of all on the curved area of the original. I can draw a line going up like this. And this is going to split my triangle into two right angle triangles. That one is the radius of the original. So that's going to be 6. And then this is the height, which is going to be 8. And hence I can find the slanted height of my original cone. It's going to be 10. 6 squared plus 8 squared square rooted is 10. You might also recognize that it's a 3, 4, 5 triangle. That's a Pythagorean triple. If you double all the sides, you get 6, 8, 10. It's worth looking out for those sorts of things to speed things up a little bit. So now I've got, oh no, I can't quite do it yet. I just want to also, if I'm taking away the curved surface area of the cone that I've removed, I just need to draw another triangle. So this is going to be from the center of the circle at the top. I'm going to create this red triangle, and I don't know the radius of that. That's going to be r. And then let's say the height of that cone is going to be h. And by the way, I want to find the height of the frustum, so that is going to be 8 minus h. I'm trying to find h here. And then let's call the curved part L. This is also a right angle triangle. So I can now write down an equation. It's going to be pi r L is the curved surface area. So pi times 6 times 10. That will give me the curved area of the original cone. And we're going to minus pi RL, that's the curved area that we've removed. And that is going to equal pi times 6 squared, that's the circle at the bottom, plus pi r squared. We can immediately just cancel out the pi's, dividing through by that. Let's just tidy it a little bit more. 60 minus RL is equal to 36 plus r squared. So if I can get L in terms of R, then I've got an equation that I can solve. We could, of course, also substitute everything for H, potentially, but I think I'm going to solve for R. And to do this, we can use the fact that the red triangle and the black triangle are similar. So if I draw them out separately, then, okay, they've both got a right angle. I've got 6, 8, 10, and then I've got H, R, L. So it must be that L divided by 10, the smaller hypotenuse divided by the bigger hypotenuse, is equal to R divided by 6, because both of these give us a scale factor. L divided by 10 gives us a scale factor to go this way. We would times 10 by L over 10 to get that length, and the same for R. You would times 6 by R over 6 to get to R. So those two must be equal because they are similar triangles. We know they're similar triangles, so I probably should have just said that, because they share an angle here, they share a right angle, and these two are parallel lines. But anyway, we know they'd have to be the same anyway. So that means that L is 10 over 6R or 5 over 3R. And while I'm doing this, I can also write down H over 8 is a scale factor. And that means that H is going to be 8 over 6R or 4 over 3R. So we are nearly there. I'm going to sub in for L into here. I'm going to solve for R, and then I'm going to be able to work out H, and I'm going to do 8 minus that to get the height of the frustum. Okay, I'm therefore going to have 60 minus 5/3 R squared equal to 36 plus R squared. That means that 24 is going to be 8 over 3 R squared. 5 over 3 plus 3 over 3. Divide through by 8 times through by 3. R squared is going to equal 9, which means R is equal to 3. And then H is 4/3 times R. So H is 4/3 of 3. It's going to be 4. And then if I put it back in, 8 minus h is also 4. When I first made this video, actually, I forgot that we've actually found the height of that little triangle. It just happens to be the height of the frustum as well. But I just wanted to like correct it. And, in a different scenario, it wouldn't be the same, of course. In this case, they are the same. Height of the frustum is 4. Nicely done.